Good day. This is our second video looking at energy. You should now know about the two classes of energy and the many forms of energy. Well, why do we care about energy? It can be very useful in our daily lives. So here we're looking at energy transformations, and we're going to start with the first law of thermodynamics, and then we're going to look at these transformations and energy transfer. So, energy cannot be created or destroyed, it can only be transformed. So in an isolated system by itself, if we start with a certain amount of energy, we're going to finish with a certain amount of energy. We do run into some problems if we get into the world of nuclear reactions, so we're not going to get into that here. An energy transformation occurs when energy changes from one form to another. So transformation, you can see the word form is right in there. So if we look at a rock being dropped off a cliff, we know, in this case, we're going from the class called potential energy to the class called kinetic. But when we're looking at transformations, we care about the forms. So if a rock is up a cliff, it has gravitational energy. As it falls, it's going to go faster and faster, and so it will have mechanical energy. So that is an example of gravitational to mechanical. A radio. Well, we're assuming it's a plug-in radio. So it's powered by electrical energy, and it's going to make sound. So that seems pretty simple. Now, energy transfers are similar to transformations. The only difference is we're not changing form. So energy is passed from one object to another without changing form. So a pool ball hitting another pool ball, we're going from mechanical to mechanical. Now, when they hit, you'll also get some energy being produced in the form of sound and low-level heat. There's something called efficiency, and we worry about efficiency in this chapter, and something called perpetual motion machines. Well, efficiency is simply the output, energy output, compared to the energy input as a ratio, and to make it a percent, we multiply by 100 and stick on a percent sign. It turns out there's no such thing as a device that has an efficiency of 100%. We always lose energy, and we're guaranteed to lose it in the form of low-level heat. That means we're going to make particles around, move a little bit faster, but we can't harness that energy. And often we'll lose it in the form of sound and things like that. So for centuries, people have tried to make a perpetual motion machine. That would be a machine that really has to be 100% efficient, so that once it starts, we don't have to add any external energy. It'll just keep going. But so far, it has proved to be impossible. So here are some crazy things. There's an Escher diagram for you. This is the idea: you have a sponge, and then these things get wrung out, so they get lighter, so they move up and come down. But of course, there's going to be friction at these different axles, so we'll lose some energy. So maybe you can prove us wrong by building this successfully. But at this point, it looks like that is going to be hard to do and fairly unlikely. So that's looking at transformations and energy transfers. Make sure you know what those mean. There are a lot of easy questions you'll see on worksheets, and a lot of times there's more than one right answer. So as long as you give an example of a right answer, you will be fine.